Hello, this is Mr. Buffington, and we are looking at points and lines again. This time we'll be doing it a little bit differently. We'll be asking ourselves if a point is on a line, but this time we're going to be asking using an equation and an ordered pair. So is an ordered pair, boom, a point on the line? And of course, practice, practice, practice. So if you're given a graph like this with 3 points on it and a line, it's easy to see which points are on the line, right? We can look and see that pretty easily. This point is not on the line, this point is not on the line, this point is on the line. 1, 0. That's not 1, 0, it's negative 1, 0. As I was saying, negative 1, 0. So we can see that that point is on the line. The point negative 1, 0 is on that yellow line. Now, what happens when you are not given the graph? If you were not given this graph and you were asked if these points are on the line, you'd have to figure it out in another way, and that's what we're going to be doing today. We're going to be given a point like this, negative 2, positive 2. And the key is to remember that each point in an ordered pair, or each number in an ordered pair, has a value. It's an x and a y. So our x value is the number that comes first, and our y value is the number that comes second. So let's take a look at some questions. Is the point negative 2, positive 2 on the line y equals 3x plus 4? Remember that each point is an ordered pair. So you see on the side here I've listed negative 2, positive 2, where x is equal to negative 2 and y is equal to positive 2. I've taken that point and made it into two variables. Now we can substitute those variables into the equation and solve. X equals negative 2, y equals positive 2. Plug them into that equation. So instead of y equals 3x plus 4, I have 2 equals 3 times negative 2 plus 4. Notice in this case that the x and the y are not in order alphabetically, right? The y value comes first, the x value comes second. It's important that we plug in the correct numbers. So 2 will go in there and negative 2 will go in here. That's a common mistake. When we see them, we want to plug them in whatever order they appear. So we want to make sure that our x value was negative 2, our y value is positive 2. Let's go ahead and solve. 3 times negative 2 is negative 6. Negative 6 plus 4 is negative 2. Positive 2 equals negative 2? Not in my math class, mister. So that tells us that the point negative 2, positive 2 is not on this line. That's what that tells us. In our next question, we're asked, is the point negative 1, positive 1 on the line y equals 3x plus 4? So in this one, we again need to remember that the point xy is the ordered pair are a set of values, x and a y. So the first one is their x value, the second one is our y value. Substitute them into that equation and solve. Our y value, 1, is equal to 3 times our x value, negative 1, plus 4. Solve. 3 times negative 1 is negative 3. Negative 3 plus 4 gives us a positive 1. 1 equals 1. That is correct. So that means that the point negative 1, positive 1 is on the line. When you get an equation that ends with a correct answer, we know that it is true. Therefore, this point, negative 1, positive 1, is on that line, y equals 3x plus 4. Your turn. I want you to find out if the point 5, 7 is on the line y equals negative 1x plus 12. Go ahead and try that one out. Hey, are you back? What did you think? Yes? No? Let's take a look at our point is 5, 7. That means our x value is 5, our y value is 7. So we are going to substitute 5 in where we see the letter x and 7 in where we see the letter y into this equation. Now, I just want to point out one more thing. Normally you don't see negative 1x. It's usually written as just negative x, but I decided to put it in there as negative 1x just to make that have less complications. But if you see it just as y equals negative x plus 12, it would be the same thing. All right, enough with that. Let's go ahead and multiply. Negative 1 times 5 gives us negative 5. Negative 5 plus 12 gives us positive 7. 7 equals 7. Yes, it does. So that means the point 5, 7 is on the line y equals negative x plus 12. That tells us that that point is a solution to this equation. Or in other words, that point is on the line. Let's do another one. Is the point 0, 0 on the line y equals negative 2x plus 7? Pause the video, try it out. Hey, welcome back. If you notice, this one is kind of nice because you get to work with two zeros. X equals 0 and y equals 0. And when you substitute that into your equation, it makes your life really easy. Negative 2 times 0 gives you 0. And 0 plus 7 equals 7. So it's quite obvious that the point 0, 0 is not on this line. We know that because 0 is not equal to 7. All right, definitely not on the line. One more. Is this one on the line? I've changed up the equation a little bit. The point 1, 2. Is it on the line 3x plus 3y equals 9? Hey, welcome back. Did you solve it? Is it on the line? I can't wait. The anticipation's killing me. I have to go ahead and solve it. I just have to. The point 1, 2 gives me my x value of 1 and my y value of 2. I'm going to substitute x equals 1 and y equals 2 into this equation. So I will have something that looks like this. 3 times 1 plus 3 times 2 equals 9. 3 times 1 is 3. 3 times 2 is 6. I've done my multiplication first. Now I'm going to take care of the addition. 3 plus 6 equals 9. 9 is equal to 9. Therefore, the point 1, 2 is on this line. The point 1, 2 is a solution to this equation. Bing! You got to remember, when you're given an ordered pair, you are given an x value and a y value in that order. Practice, practice, practice. Here are some other videos you can check out. I hope that lesson was helpful for you, and as always, have a wonderful day.